Now let us see the working of a piston air pump. So we have a pump in which we have a gas, ideal gas here, and we want to reduce the pressure of gas in this body vessel. So we have a piston here. So the working of this piston air pump is that in each stroke, this is the volume V, in each stroke it goes here and there will be some openings here, valves. So each volume in each stroke it scoops out delta V volume. So what happens when we give a stroke, then in each stroke it takes out delta V volume of air from it. And what happens, so when it takes delta V volume, then the remaining gas fills this. So the volume never changes here. And all these things, suppose, is done under isothermal conditions. Then we have to see that how the pressure is going to be reduced after n piston strokes. You may be tempted to think that by applying Boyle's law, that PV is equal to constant at isothermal. If the temperature is constant, then V, if V is not changing, then so is the pressure should not change. But this law is true if number of moles is constant, that given mass of the gas is fixed. But what is our here purpose? We want to create here low pressure. So we are taking out some gases, some moles, and so the number of moles is decreasing, and so the remaining left out occupies the same volume. So as a result, V is constant, number of moles is decreasing, so is the pressure should decrease. So let us find, so let the initial pressure of the gas in a vessel be V. So this is the initial volume, and in each piston stroke, delta V volume of gas is scooped. So we have to find how much piston stroke is required to reduce the gas pressure in the vessel eta times. So this is what we are going to find. So what we do, what is our strategy to solve this problem? That when we scoop delta V volume, we take some of the gas. So when we take some of the gas, its contribution, its partial pressure is taken out. As a result, the total pressure is reduced. So let us see how we can do. So total pressure is P. So let the pressure after the first stroke be P1. So what is P1? So P1 will be, initially pressure was P0 minus the contribution of that delta V volume. This is delta V volume. So this volume of gas is taken out from this. So that means contribution of this pressure, this gas in the total pressure is called its partial pressure, that has been taken out. So what is the partial pressure of this gas? So partial pressure is P0 into mole fraction, that is delta V by V. So this is the fraction, mole fraction of that taken out. So this is the partial pressure. So we have this as P0 1 minus delta V by V. So this is the pressure after first piston stroke. Now the pressure the pressure after the second piston stroke is P2. That will be again in a similar way, it is P naught. P1 is P naught times this, so P2 is P1 times 1 minus delta V by V. That becomes P naught 1 minus delta V by V whole square. Thus the pressure after n piston stroke is given by Pn is equal to P naught 1 minus delta V to the by V to the power n. So this is the pressure. So now the pressure becomes P by eta, P naught by eta after n strokes. So this is 1 minus delta V by V to the power n. So this cancel. Let us take log. So ln 1 by eta is ln n times ln 1 minus delta V by V. So this is minus ln eta is equal to n times ln 1 minus delta V by V. So we have, this is n. So number of strokes is minus ln eta by ln 1 minus delta V by V. So this is the number of strokes required to reduce the pressure in this vessel eta times. This is how a piston air pump works.